All right. So let's start with introduction to statistics, okay? So you've heard of problems like, okay, you have 15 green balls, 4 orange balls, and 2 purple balls in a bag. What's the probability of you pulling out a purple ball or something? That is statistics, okay? Now, to calculate probability. So the main thing with statistics is what we call probability. Okay. And the probability is basically the calculation of the chance of something occurring. Okay. Now, let's take, for example, a situation like this, right? Okay. So you have a bag with 3 red marbles, 4 green marbles, 2 yellow marbles, okay? Now, you want to know the probability of pulling out a red marble. So the way you calculate this is the probability of something is the total in the denominator, and in the numerator, it is what you're pulling out, or what is the outcome that you want, what we call the desired outcome. So if I want to pull out a red marble, I have 3 red marbles, and the total number of marbles that I have in the bag are 3 plus 4 plus 2, which is 9. So 3 9ths, which is 1/3, or if you convert this into a fraction, it's about 0.33 or 33%. So you have a 33% or 0.33 probability of pulling out a red marble. Okay. So basically, whenever I give you a probability problem, you say you put the desired outcome over the total number of outcomes that can occur. So let's talk about a coin flip. What is the probability of getting a heads on a coin flip?
50.
50. And how did you get that? Well, a coin flip has heads and tails, okay? And so there's 2 total possibles, and you want heads, which is 1. So desired outcome over total, which is 0.5. Okay, or 50%, right? Now, the total number of events that can occur has a funky name to it, okay? So heads and tails, or the total number of marbles, is known as the sample space. The sample space. That's the total number of outcomes that can occur. Okay. So let's take, for example, let's say 2 3-sided dies. Okay, so 2 of them. So each 3-sided die has numbers 1, 2, and 3, and you have 2 of them. What is the sample space? Well, what is the size of the sample space? Well, you can get 1 and 1 on the first die. You can get 2 and then 1 on this first die. So 2 on the first die, 1 on the second die. And you can get 3 on the first die, 1 on the second die. Then we can do this again. 1 on the first die, 2 on the second die, 2 on the first die, 2 on the second die, then 3 on the first die, and 2 on the second die. The third way is 1 on the first die, 3 on the second die, 2 on the first die, 3 on the second die, 3 on the first die, 3 on the second die. So the total sample space is 9. So there's 9 total outcomes. Okay. Does everyone see how to calculate a sample space? You just write out all possible outcomes and then you just add them all together. That's your sample space. Okay, let's do another one. Let's say, for example, you have 2 dice. Okay. One 3-sided and one 6-sided. Okay. What is my sample space? Calculate it, please. What's the size of my sample space? Okay, what'd y'all get? Okay, let's do it together. Okay, so the first probability is 1 on the first die, 1 on the second die. The second possibility is 2 on the first die, 1 on the second die. Next one is 3 on the first die, 1 on the second die. Then we do this again. We do 1 on the first die, now 2 on the second die, 2 on the first die, 2 on the second die, then 3 on the first die, 2 on the second die. Then again, 1 on the first die, 3 on the second die, 1 on the first die, 2 on the first die, 3 on the second die, 3 on the first die, 3 on the second die. Then again, 1 on the first die, 4 on the second die, 2 on the first die, 4 on the second die, 3 on the first die, 4 on the second die. Keep going. 1 on the first die, 5 on the second die, 2 on the first die, 5 on the second die, 3 on the first die, 5 on the second die. Then last one, 1 on the first die, 6 on the second die, 2 on the first die, 6 on the second die, 3 on the first die, 6 on the second die. So these are all my combinations, all right? Now, what is the sample space? Well, 1, 2, 3, 4, 5, 6 rows of 1, 2, 3 columns, so 18 total outcomes. Does everyone understand how to calculate sample space?
Mm-hmm.
I want to do one more. Mr. Harris, would you like to do one more? Or are you good?
I feel like I'm good.
Okay. So let's say I want to calculate let's take, for example, let's do this one right here. What is the probability of me getting, if I take these two dice and roll them, what's the probability of me getting two numbers that add up to 5? Okay. Two numbers that add up to 5. What would be the probability of that? Well, the way we do that is say, okay, well, which one of these, how many of these combinations add up to give me 5? Well, 1 and 4, 2 and 3, 3 and 2, okay? And that's pretty much it, okay? So there's 3 rows or 3 combinations that add up to 5, and there's a total of 18 different combinations. So the probability is 1/6, or I don't know what the decimal is. Or 0.17, or 17%. Okay, does everyone understand how I did that?
Yes.
Okay, so let's have you guys do one. What's the probability of me rolling a a 5? No, a 7, a 7. What's the probability of me rolling a 7? Okay, what'd y'all get? What's the probability of me rolling a 7? All right, so let's walk through this. How many of these combinations add up to 7? Well, 1 and 6, right? 2 and 5, 3 and 4. All 3 of these add up to give me 7. There's no other combination that adds up to give me 7. So 3 desired combinations out of total of 18, which gives me, again, a 1/6, which is 0.17. Now, let's say, for example, I wanted to know what's the probability of me rolling a 7 or a 3. Okay, a 7 or a 3. Okay. Now, when you're talking about, these are what we call compound probabilities. Okay. And there's two types. There's the or probability, and then there's the and probability. Okay. So the first compound is an or, the second compound probability is an and. Now, in probability, when you hear the word or, think addition. Okay. And when you see the word and, think multiplication. Okay. So what's the probability of me rolling a 7 or a 3? Okay, so remember 7 or 3, so plus. So we calculated this probability of 7 is 1/6. Okay, and we said we can calculate the probability of rolling a 3 by saying, okay, well, which combinations give me a 3? It's 1 and 2 and 2 and 1. So the probability of me getting a 3 is 2 desired outcomes over the sample space of 18, which is 1/9. So the probability of getting a 7 is 1/6. The probability of getting a 3 is 1/9. So we have to add these. Okay, so remember, how do we add fractions? We have to find a common denominator. So the probability of rolling a 7 or a 3 is 5/18, which, if we do the math, 5 divided by 18 is 28%, or 0.28. Okay, so or is addition and is multiplication. So let's do another one. What's the probability of rolling a 3 and a 8? A 3 and an 8. Calculate the probability. 3 and 8. Guys, I think I may have confused you. I don't want 3 and 8. 3 or and 8. Sorry. Three or an 8. Okay, so let's do this. We know the probability of getting a 3 is 1/9. And we can look at how many combinations give me an 8. Well, 2 and 6 and 3 and 5. Now, the probability of rolling an 8 is 2 out of 18, which is also 1/9. So 3 or 8 So 1/9 plus 1/9 is 2/9, which is approximately, if we do the math, 22% or 0.22. All right. Now, let's talk about the fundamental counting principle. And the fundamental counting principle says that if you have multiple events, okay, and each event can be done n number of ways. So let's say you have one event that can be done n ways, you have another event that can be done m ways, and you have another event that can be done p ways. The total number of combinations is the multiplication of each number of ways each event can be done. So n, m, p, n times m times p. Now, let me give you an example of that. Let's say, for example, you go to Subway, okay? And they have 3 choices of breads. They have 6 choices of vegetables, and they have 5 choices of meats. If you could only pick one from each category, so you're going to pick 1 bread, 1 vegetable, 1 meat, how many different sandwiches can you have? Well, think about it. The number of breads that we can choose are 3. The number of vegetables that we can choose are 6. And the number of meats that we can choose are 5. So 3 times 6 times 5 gives me what? 30 times 90. Okay. 90. So there's 90 different sandwiches that we can make. Now, this might not seem obvious, but let me give you another example. Okay. So let's say you go to an ice cream shop and they have chocolate, vanilla, and strawberries. Okay. For strawberries for toppings, and each and they have well, for ice cream, and each ice cream you can either have sprinkles, nuts, or fruit. So you can choose chocolate, and you can add either sprinkles, nuts, or fruit. Vanilla, you can add either sprinkles, nuts, or fruit. And strawberries, you can add sprinkles, nuts, or fruits. So how many combinations? Well, you got chocolate and sprinkles, chocolates and nuts, chocolates and fruit, vanilla and sprinkles, vanilla and nuts, vanilla and fruit, strawberries and sprinkles, strawberries and nuts, strawberry and fruit. So the total number of combinations is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 different combinations. And we could have easily gotten that instead of doing this method. We could have said, okay, well, there's 3 flavors and 3 toppings per flavor, so 9 total combinations. And that's the fundamental counting principle. Okay, so if you have multiple events, each event can be done X number of ways or N number of ways. The total number of combination is the product of all of those number of ways you can do each event. So let's go back to the dice problem. So remember we said we had a 3-sided die and a 6-sided die. How many total combinations can we get? Well, remember the 3-sided die was in 1, 2, and 3. 6-sided die was 1, 2, 3, 4, 5, 6. So when the first die can be done 3 different ways or 3 different combinations. The 6-sided dice has 6 different combinations, which gives me 18 total different combinations of the 2 dice together. And you saw that from what we did here. That was 18 different combinations that we were able to get. And that is the fundamental counting principle. So let's do one more example. Let's say you go to let's say you go to a pizza place, okay? They have 5 different crusts. They have 4 different meats, and they have 6 different veggie toppings. If you can only choose one from each one of these categories, how many different pizzas can you get? Calculate, please. How many different combinations of pizzas can we get if we have a choice of 5 crusts, 4 different meats, and 6 different vegetables? Okay, so what'd y'all get? How many different pizza combinations can we get? Mr. Harris, how many combinations did you get? I think Mr. Harris is on mute. Okay. Mr. Alcantara, are you following along with what we're doing? Because you came in a little bit late.
Yeah, I'm still working.
Okay. So how many different pizzas can we get? Okay, so 5 pizza crusts times 4 meats times 6 vegetables. And if we multiply it out, we get 5 times 4 is 20 times 6 is 120. So 120 different combinations or pizzas that we can get. Any questions? Is everyone good? So in summary, we talked about the fundamental counting principle. We talked about what is probability. We talked about how to determine sample space and how to calculate or do basic probability. It's the desired event over the total number of outcomes, or the total number of outcomes being your sample space. Any questions? Okay, so if there's no more questions, then I will see you guys tomorrow. Right? Have a nice day, guys.
Have a nice
Thanks,
day,
Mr.
Mr. D.
Yeah.